Hi everyone, and welcome to this session of Global Angular Meetup. I'm going to be your host today. I'm Daniel Marin. I'm a software engineer at Labs, and well, we bring you today some really awesome speakers. I hope you are as excited as we are with this event. So let's get started. I just want to remind everyone about our main sponsor is Labs. Thank you, Labs, for bringing us this space to learn more about Angular. Labs is a company based on giving modern web development consultancy, development, staff augmentation, and much more. So feel free to reach us out via Twitter at Labs or via our website, this.labs.com. So before we go to the event, I have some announcements. Just if you are interested on GraphQL, we're having a global GraphQL meetup coming soon on July 7th. And then we're going to have another of these sessions, but React on July 9th. And we have another of these same sessions of Global Angular Meetup on July 14th. And then we have a Global View Meetup on July 16th. And same as with Labs, you can follow us on this.media if you are looking for more information about the online events we do, the blog posts, or if you're interested in giving a talk, feel free to reach us out. We're always looking for good people that wants to share their knowledge. For today, we have some really awesome speakers. We have Nicholas Jamieson. He's a Rxjs core team member and a freelance front-end developer. And we have ShareWith. She's a Azure developer technical lead on Microsoft. And for today, we'll have we have first Nicholas, and then we're gonna have Sherry. I leave it to them to explain what they're talking. So I'm not gonna talk anymore. I'm gonna give the stage to you guys. So Nicholas, it's up to you.
Thanks, Daniel. I'm Nicholas. I'm on the Rxjs core team, and I'm going to be talking today about a concept that I call pluggables. So what's a pluggable? So usually when you're dealing with Rxjs, you're composing behaviors out of individual operators and piping them together. And to change the behavior, you'll choose different operators. So what I call a pluggable is something into which you're actually going to insert an operator to change the behavior. So a pluggable API provides some basic behavior that you can create a variant of by passing in a different type of operator. So Rxjs itself has some pluggable APIs. It has subjects, so subjects plug into multicast and give you a variety of different behaviors for sharing, for publishing, and also has schedulers. So schedulers plug into a bunch of APIs to control how those APIs work in a time basis. So we'll have a look at some of the ways that you can use pluggable APIs in your own applications, and in particular, we'll have a look at some pluggable APIs, 3 pluggable APIs that are published in a package called Rxjs pluggables. So we'll go through a bunch of examples using these 3 APIs, and each of these examples will use Angular and we'll use the GitHub REST API. So the first thing we'll look at is debouncing. Now, debouncing is probably the classic use case for Rxjs. When you first start with Angular, one of the very first things that you see, one of the very first things that I saw was taking in input, taking the stream of values that were coming from that input, debouncing them, and then sending them to switch map to perform some sort of API call. So we'll have a look at that with a marble diagram and talk about some of the consequences of doing that. So up the top, we've got our inputs, and down the bottom, we've got our matches. So in this case, we're going to be taking an input and we're going to use it in a find user component. So we'll take the input and we'll call GitHub's search API to get users that match the characters that have been entered. So the user starts off and they type in a D. Now the debounce implementation is going to have an internal timer. So we're using debounce time, and that timer ticks along, and when it gets to the end, it will fire off a notification, and we'll use that to use switch map to hit the GitHub API and pull back some information to find the users that match the character. So if the user types another character before that timeout has elapsed, that timeout's aborted, a new one is started, and this happens again and again. So if the user takes longer to find the next character they want to type. We've got DE in the buffer. If they're just looking for the next character and the timeout elapses, our API call starts inside the switch map. Now, that API call might take a bit of time. And if during that time, the user finds the key they were going to press and they press V, so they've got dev in the input buffer now, that comes through and we have another timer start in the debounce implementation. But if our API call finishes while that timer has not yet elapsed, we'll get a value from the API, and that value will come through to our matches. So we'll get the results for our search for DE, which was in the input buffer, showing up in a user interface, even though they've typed DEV. Now, when the timer for the debounce implementation for the dev key press elapses, we'll start off another API call, get the result, and then that result will be displayed in the user interface. So this is all fine. If the user's typing fairly quickly, we're going to ignore most of the character presses. We're not going to make we're not going to make an API call for every single character press. But if you look at the diagram, there's something that's a little bit amiss. We've got this result that's shown in the user interface, even though the user has pressed the V character. So they've typed dev, and the user interface has shown them the results for DE. So that's not ideal. What would probably be better would be to not only cancel the switch map when the debounce timer elapses, but to also cancel it when a key is pressed whilst that API call is actually happening. So in our find users component, we'll use one of the pluggable APIs that I've added to this package. So we'll start off by looking at the templates. It's a very simple form. It doesn't have very much in it. It has an input control, and it has a list beneath the input control that takes an observable of users and just shows the logins for each of those users. So the component looks like this. We've got a form up the top which contains the username control, and we have our observable of users. Now, the user's observable is just derived directly from the value changes. So as the values change, we will get the users by running them through this pluggable operator, which I've called switch map with, and I've passed the debounce time to switch map with. Now, this is very similar to what you would be doing with switch map, but ordinarily you would have the debounce time before the switch map. So switch map with is a pluggable operator. I'm taking the debounce time operator and I'm passing it to switch map with. Now, the reason I'm doing this is because when we have a look at the implementation of switch map with, you'll see that there's a bit of composition that goes on inside. So that's the primary difference between using debounce time followed by switch map with. The selector is going to be basically the same thing. It's going to hit the GitHub API. It hits the search endpoints. It gets the users that match the username or the portion of the username that's been typed in so far, and it displays the items beneath the input. So if we have a look at the implementation of switch map with, we'll see how it works and we'll see why you might want to choose this pluggable approach. So switch map with takes a project function the same way that switch map takes a project, but it also takes the operator. So it takes a before operator, and that before operator is fitted into an internal pipeline. So internally, we use three Rxjs operators to build this. So we call publish on source to give us a shared version of the source. Now, what publish does is it allows us to subscribe to the published source as many times as we like inside the selector, but only affecting a single subscription to the source. So if you published twice inside this selector, it's the source of the pipeline inside the selector, and it's also used in take until. So what this allows us to do is to use changes to the source to not only switch after the debounce time has elapsed, but also to switch as soon as the key is pressed. So when the user, in our example, presses the V key, it will start a debounce time in the before, but it will also finish any pending API calls via the take until. So what we can do with this is we can pass in an operator to do any of these sort of delaying things before the switch map. So you could write your own debounce time that did this, but by passing in the operator, it allows us to use this same structure, basically publishing the source, inserting the operator before the switch map, and also using the published source with a take until operator to terminate it if a new value is coming in. So the idea is we can pass in any sort of delaying operator where we know as soon as we've received some input, any switch map that is currently pending should be ended. So we can use it with debounce time, we could use it with sample time, we could use it with delay, or we could use it with audit time. So we've got a fairly flexible operator that we can use to solve the problem of these results showing up when we know we don't want them. So we know that the source has emitted another value, and we know that we can use that and take until to abort any API calls that are happening. So that's a very simple pluggable API, and that's the essence of what these things are about. We want to pass in an operator so that we can have some structure, and the structure in ShareWith, switch map with, is to set up the pipeline, put the operator before the switch map, and also use the take until. So it also means that we can test this. So we can encapsulate this behavior, this terminating the inner observable upon a new value coming from the source, and we can test that. And we can then go and use it in our application. If we had this much code sort of inside an input, beside an input inside a form, it might be something you might look at and wonder if you need to test it. But we can test this thing in isolation very easily. So it gives us a nice encapsulation boundary around something that we can test, and then something we can just go and use in a component and be very sure that it's going to work. So the next of the APIs that we're going to look at deals with graph traversal. So a graph is something where you have nodes, and those nodes are connected by edges. So a graph doesn't have to be a tree structure. Pagination is a graph. So the API, the pluggable API that does this is in the package, and it's called Traverse, and we'll have a look at how it works. It's based upon using expand. But in terms of the traversal, the concept that it uses is of a marker. So a marker is basically something that gives you a reference to the next node. It's something that goes from one node to another. It's basically outlining an edge. So when you start the traversal, the marker is undefined. So we start the traversal, maybe you have an API call. In this case, what we're going to be doing is we're going to be retrieving starred repos for a particular user. So hit the API and we'll get these repos in pages. So the first time when we start the traversal, we're not going to have a marker, we'll have undefined for the marker. When we receive that page, we'll also receive the marker for the next. So we can basically step through the pages, receive them. So expand does this for us. We can just allow this thing to chain, and it will just traverse through the entire set of pages. Now, the example that I used when I was preparing the code for this, I used Jason Miller's GitHub account because he has something like 4,000 starred repos. Obviously, you don't want expand to be going completely wild and retrieving 4,000 starred repos, because you can't display 4,000 items in a list in a user interface. It makes no sense at all. It's bonkers. So what you want to be able to do is you want to be able to control how the pagination traversal is actually happening. So we'll do that, and we'll do that using an observable. So we'll pass into our pluggable API a factory that retrieves each page, and a notification observable that we can use to control the traversal. So we don't immediately receive 4,000 repos. We'll receive one page, and then when we fire the notification observable, we'll receive the next page. We can iterate it that way. Another use case for traverse is when you are retrieving information, and then after the traversal, you are doing something with the information that you've retrieved. So you're performing another operation. An example might be if you're retrieving the repos from GitHub. Once you've retrieved the repos, for each repo that you might retrieve, you might want to retrieve the contributors. And if you do that, you're going to have a very slow process after your traversal, which is to say the lookups for each repo that you get on each page are going to take a lot longer than the retrieval of the page of repos themselves. And when that happens, you end up in this situation where by the time you've actually done the operation to retrieve the contributors, the expand has chunked through another bunch of pages, and you're in this situation when you've got back pressure. You've got these things building up, and you're simply not going to be able to deal with them in time because you have a slow process after a fast process. So there's a way that the pluggable Traverse API also lets you deal with these situations. So we'll have a look at a component. This component is just going to show a list of repos. These will be the starred repos that we retrieve from the GitHub API. So we've got a list. It's just going to have asynchronous observable of repos. We use the async pipe, and we use a track by to make it reasonably efficient. And beneath that, we're going to have a button. The button's not going to do very much. It's going to have a click handler that's just going to next a subject, and that's going to be our notification. So when this shows up in the user interface, you'll be able to press the button, say, I want some more repos, press it again, more repos. Now, the component looks like this. So up the top, we've got our observable of repos. We have a subject for our button. And then we have a traverse call. So the Traverse API is an observable. It's assigned to the repos, and it takes a factory. That factory is going to work with the GitHub API to retrieve each page. So essentially, it's going to visit each node in the graph, where the nodes in this particular API are the groups of repos, the pages of repos. Down the bottom, we've got this bit that we will come back to. It's going to take the results and turn them into array, because Traverse, when it chunks through these, retrieves each page and then emits a repo. So Traverse is going to be emitting a stream of repos, and the scan down the bottom turns those into an array for our list. So what happens in the factory is probably the most interesting part. The factory gets past the marker, and as I said before, the marker is what indicates the node. So when we first start off, we'll come into the factory, Traverse will call the factory, and the marker will be undefined. So in that case, we're going to retrieve the first page, which means we're going to use this URL to retrieve Jason's starred repos. We're going to call get using these options where we say we want to observe the response because we need the header. So when we receive the response from the GitHub API, the headers that come with the response will include links, and those links are what, in this example, constitutes the marker. So we take the response and we map it using a two-node function. Now, the two-node function looks like this. So it takes a HTTP response, that's the one we receive from GitHub, and it does two things. The first thing it does is it looks through the headers. It finds the link header, because that's how GitHub's API handles pagination. You'll receive a response. The response has a link header, and that link contains two URLs. It contains one where the rel is for the next page, and it contains another where the rel indicates that it's the last page. So this snippet of code goes through the link header. It extracts the URL that corresponds to the next rel, and if it's there, we'll return that as the marker. So if it's not there, we have no markers, and we know we've reached the end of our graph. The values in this case are the repos that are in the response body. So this is how the factory drives the Traverse implementation. It returns two things. It returns two things to Traverse. It returns the markers, and it returns the values. So these are the markers and the values for a particular node in the tree. So in this case, the nodes are each page that we receive from the GitHub API. And in that page, we'll have the repos, which are the values, and we'll either have a URL for the next page or we won't. So we'll either have one marker or none. This is a general sort of structure. So we can use this structure to traverse any type of graph. So if you think of, it's not always the case that you're going to have one marker and multiple values. You could have multiple markers and only one value. If you think of a family tree is a graph. If we were using traverse to traverse a family tree, we would only have one value. So in our factory, we would return to the traverse implementation the value, which would be the person. So we would have an array with one person in it. And the markers would depend upon which direction you were traversing the family tree. If you're heading upwards toward your ancestors, then the markers would be the two nodes that represent your parents. If you're heading the other direction, the markers might be the nodes that represent your offspring. So it's a general way of traversing graphs. It works in this case because the GitHub pagination API is a very simple linear graph. So if we come back to the components, we also pass in our subject as the notifier. So what this lets us do is each time the user presses the button, we fire off a notification from the subject. And that is going to tell the traverse implementation that it needs to move to the next marker. So we can control how the traverse implementation is going to traverse the graph. We're going to, every time we press the notify, every time we tick over the notifier, it's going to move on to the next, traverse an edge, go to the next node, get the page, and add that information to our list of repos. So in this case, we've used a subject and we've wired that subject up to a button, but we could wire that subject up to a number of different mechanisms. It doesn't have to necessarily be a button. What we could do is we could base it on the scroll position. So if we're scrolling through a list, as we scroll to the bottom, we could have a notifier that notices that you've reached the bottom of the list. It fires the subject notifies traverse, the traverse implementation then gets the next page and adds more to your list. So you could use this implementation to implement an infinite list. So if we have another look at the bit that was down the bottom, the bit that's down the bottom uses an Rxjs operator called scan to basically to accumulate all of the repos that are coming out of Traverse, because Traverse is just going to emit each repo that it receives from a node as it traverses the tree. And we're going to use scan to collect those into an array so that we can use that array to feed our list. Now, the way I'd use Traverse for pretty much things up until now, up until writing this example for this talk, was in a different way. I wasn't actually accumulating things in an array. So this is fairly tedious. We shouldn't have to write, take a scan on the end to get the results for our traversal every time we want to do it. So I'm going to add to the API an option. I'm going to add an accumulate option. And if that accumulate option is true, internally it will accumulate the repos or whatever it is you happen to be traversing, and then we'll emit those. So it'll emit an array that's going to grow instead of repo by repo. And the reason I hadn't done this before is because most of the time I'd used Traverse, it had been in the second of those scenarios that I mentioned when we looked at the diagram. I've used Traverse when I've been performing operations on nodes that have been traversed. And those operations were potentially slow. And to avoid back pressure, I wanted to make sure that those operations were done as part of the traverse. So rather than adding the operator after traverse, which showed, in which you saw we got into back pressure problems when we looked at the model diagram, I wanted to have that operation happening during the traverse. So traverse would move to a new node, perform the operation on those new nodes, and then when that operation had finished, it would move on to the next node. And it worked that way by accepting an operator. The same way that we passed an operator to switch map with, Traverse is not only pluggable in that we can plug in a factory and we can plug in a notifier, we can also plug in an operator. So instead of passing a notifier to the Traverse implementation, you can pass in an operator. And what the operator is, it's an operator in the sense of any other Rxjs operator. It receives an observable. In this case, it's going to receive an observable of repos, and it's going to return an observable. So you can receive an observable of repos, And it might be returning an observable of, say, the contributors for those repos and then doing something else with them. So we can use this mechanism to plug in to the Traverse implementation an operator that lets us do things while the Traverse is happening and avoid back pressure because we're controlling it. Essentially, the operator that's plugged in internally is wired up to the notifier, and the notification happens when the operation is finished. So it allows us to take an observable operator and stick it in to the plug it in to the implementation of Traverse, which is really something I've found to be quite useful. The third and last pluggable API that we'll look at deals with sharing. The context we use for this is, we'll imagine we have a repo service in our application, and that repo service has a get repo function. So we'll pass in the name of the repo. We'll use the GitHub API to retrieve information about that repo, but we also have in our components, we can imagine that we have a component that's going to deal with the repos and several subcomponents in that component that also deal with pull requests. So rather than have each of those subcomponents directly access the repo service to retrieve the pull request, we'll compose a pulls observable and we'll send that out of our repo service along with the repo data. So subcomponents can grab pulls and then they can retrieve the pull information. So because multiple components in our component tree are going to be accessing the pulls, we want to share those pulls. So the pulls are basically obtained using Traverse, then converting it to an array. And to share it, we'll use share replay and ref count. So the ref count to share replay means that if the ref count drops to 0 and the source hasn't completed, it drops the subject and it'll restart next time someone connects. But if the source completes, as far as share replay is concerned, that's it. So it will keep those results, it'll keep those pull requests for that repo forever, or until that observable is discarded and a new one is obtained. That might be what you want, but if you do have subcomponents where people might be navigating to those subcomponents and you wanted to have the pull request essentially up to date, this mightn't be what you want. So you might opt to use share instead. So if you use share, the Rxjs operator share, it's completely ref counted. So anytime the ref count drops to 0, it will discard its subject and the next subscriber will affect a new subscription to the source. So it will go back to the API, traverse them, get the pull request and return them to the subscriber. So this will make sure that everyone's got up-to-date data. But if we use this approach, we could have more traversals and more retrievals of the pull request than we really need. So something that's come up a few times in my experience has been people talking about wanting different sort of semantics for sharing observables. In particular, this sort of semantic. So the first subscriber to the shared observable affects an API call. And whilst that API call is happening, a second subscriber subscribes, then the API call finishes, but the shared observable doesn't immediately discard that subject. It might keep it for a certain period of time. So there's a bit of a delay before it lets the ref count drop to 0. If nobody else subscribes during that delay, it'll drop to 0 and be discarded. Then next time someone subscribes, it'll kick off a new subscription to the source. But if someone does subscribe whilst that delay is still ongoing and hasn't elapsed, that third subscriber receives the already cached, already shared, completed results. Now, it's possible to build your own sort of reference counting in front of Rxjs's multicast, and I've done that in the past, but it's problematic, and there's some edge cases and there are some bugs. In particular, the problematic part is that multicast will get rid of the subject when the source completes. So If this were an implementation that was sitting on top of multicast, when this third subscriber subscribes, instead of receiving the payload that the first and the second subscribers received, it connects and it gets a different subject. It gets a different subject, and that subject is a new subject. That subject doesn't have the information that was retrieved from the source. And in fact, that subject won't receive any information from the source until somebody else subscribes to the shared observable. So it's a bug and it's less than ideal. So one of the other APIs that I've added to Rxjs pluggables is this API, and it's called ShareWith. And ShareWith takes a strategy, and there are a bunch of these strategies. This one is delayed ref count. So it does what we were looking at in the diagram. When the ref count drops to 0, it will wait for the specified delay period before it goes and disconnects and reuses the subject, which means we can use this as a fairly basic case. So if we did it using ShareWith with a delayed ref count, when a subcomponent connects and receives the repos, those repos will stay available for the specified period. And if another component connects, it will get those repos that are in the cache. But if nothing happens for, say, 30 seconds, and then another component connects, it'll affect a new subscription to the source, and it will retrieve those repos from the GitHub API. So there are a bunch of strategies that can be passed to ShareWith. There's the default reference count strategy, which is essentially the same as you get with Share. There's the delayed ref count strategy that we've looked at here. There's a limited ref count strategy, which won't connect to the source until at least a certain number of subscribers have subscribed. And there's a scheduled ref count strategy, which subscribes and unsubscribes on a specified scheduler. So the way this works is the strategy that's passed to ShareWith has this shape. Once again, it's injecting an operator into the pluggable API. So we're going to plug an operator in. It's going to fit in with the infrastructure that's inside ShareWith, and it's going to coordinate with ShareWith when it connects. So ShareWith, when it receives a strategy to create the operator, it passes a connect function to a method returns the operator function, which gives the operator, which is going to mirror what it's receiving from the source, the opportunity to do its own reference counting. It can do its own reference counting. It can do whatever it likes. And it can call connect when it sees fit. So the limited strategy will call connect once the number of subscribers that have subscribed has reached the limit. It's very flexible in terms of what you can do. The second part of it is there's an API that's used internally inside ShareWith, which gets called to determine whether or not a subject should be reused. So in conjunction with passing in an operator and passing in this should reuse subject, it gives a lot of control to strategies that can plug into ShareWith. So to sum up, the three APIs that we've looked at have used this concept of plugging in operators and factories and notifiers to encapsulate basic functionality of which we can get variance. So we've done that with cancellation by passing in a different delaying operator, whether it's debounce time or audit time. We've done it with back pressure and control graph traversal, and we've done it with sharing. So one of the reasons why I find this sort of approach useful is because it encapsulates the basic approach, the basic behavior, but allows you to derive variance from it. And that encapsulation helps, in this case, the three that we've used, the three APIs that we've looked at are fairly common. So it sort of makes sense to treat them as reusable, which is why they're published in a package. But I think this approach also makes sense for just using it as an encapsulation boundary within an application. So you can build the basic behavior that you want, and you can use the injection of operators to inject app-specific functionality into your behavior. And the thing is that it makes that behavior testable, and it makes that behavior testable apart from your application. So if you have a component that's dealing with, or a component or a service that's dealing with repos and particular APIs, testing traversal type behaviors is fairly complicated because you're dealing with not only the API, you're dealing with the traversal. So you could use this pluggable approach to create a testable encapsulation of the basic behavior, test that separately, and then have some confidence that you can use it in your application. So I published a package called Rxjs pluggables. It's on GitHub if you want to check it out. The documentation is something that I'll be writing later today, so there's not very much there at the moment. But if you'd like to check it out, explore the approach, see if it'll work with you in terms of helping you create testable encapsulations inside your applications. By all means, have a look and see what you can do with it. I'm on Twitter. My DMs are open. If I have time, I'm happy to answer questions and things like that. And I also look forward to seeing what questions you have for me after my talk. So thanks for listening.
Thanks, Nicholas. Oh man, we're out of time, but you were just killing it, so I just couldn't interrupt you. I'm sorry for everybody that's here, and I was hoping for him to finish before. I just couldn't stop you. I'm definitely taking a look at that repo right away. And now I'm gonna take you out of the stage, Nicholas, if that's okay with you. And if anyone has a question for Nicholas, please just drop a comment. He's gonna be answering them as soon as possible. If not here, via Twitter, right, Nicholas?
Yeah, sure.
Excellent. Well, let's bring you here, Cherry. Thank you. So you're ready? It's up to you now. I leave the stage to you. Bye. Sorry, I think you're muted, Sherry. Just don't worry. That's okay. It happens to everybody. That's why virtual conferences are different. Visual things. Now I can hear you.
I should be fine now.
Yeah,
okay,
bye.
so let's go back here. Okay, so let's do it again. Perfect. So, hi everybody. Thanks for joining this talk. My name is Sherry Liz, and I'm working as a Azure Developer Engagement Lead at Microsoft. I'm based in Copenhagen and in Denmark. And apart from my daily work, I am the chairwoman of an association which is called Hack Your Future, where we are helping people from disadvantaged groups that they have zero or limited access to the education system in Denmark to go through an intensive 7-month course to learn everything that they need to join the job market as front-end developer. If you ever want to sponsor this association, the best way to do is that to hire a graduate or give them a chance to be an intern at your company. You can always contact me about this or go to hackyourfuture.dk and then find all the information there. I'm also pretty much involved in the Angular community. We're organizing different conferences and meetup. You might have heard of NG Vikings and NG Spain. I am one of the organizers there as well. So let's start by actually showing you that what I have built. So as you can see here that this is a pretty simple app, nothing fancy, and there is a live view of me. And when I take a picture, it transcribes it to an emoji. So so I can and it's totally fully pictured that if I want to share it, save it, you can see I draw it here. So we can try it again to be shocked. Yeah, see, it works. So and then what I did here is I analyzed the picture with machine learning techniques to get the emotions out of it, and then later on I draw it on a canvas, and then we are going to see that how I actually did it. I mentioned that I use machine learning techniques to do it, and I assume that some of you, like me, you might come from a totally background of being a front-end developer. So I want to have a very quick overview of some of these terms. So if you start with the artificial intelligence, one of the common the description of it on internet is that AI is a simulation of human intelligence processes by machines. And these processes include reasoning, remembering, learning, and self-correction, which basically means that is all about having machines to be like human and be able to make decisions, learn new things, and remember what they learn as well. And as for the machine learning, Arthur Samuel in 1959 says that machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. So basically, it means that we shouldn't be there to command the program to, if this happened, do this. If that happened, do this. So the machine should be able to make decision on its own, just like us. And for example, something here that when I look at this picture as a human, I can see that there is a cat and there is a dog in this picture. Without I personally met this cat and dog before, because I saw them before, I can recognize a pattern and just say that it's a cat and it's a dog. And that is how actually it should work. And there are techniques like artificial neural network, deep learning, Bayesian networks, and clusterings that allows us this technique allow us to write such a program. So in a whole, artificial intelligence is all about a computer making the decision and being able to do the self-correction, and we apply that with these techniques in while we are using the machine learning. So let's see that how it works. So if I want to, for example, teach machines to detect a dog, I normally should have a set of data. For example, in our case, a set of data that contains dogs. And what I should do is that I should go through this algorithm based on my situation. I should use one or multiple combination of these to try to find out how the dog look like, to find those patterns. And this process is normally that is not a one time. You should go through it again and again until you have something called model that it contains is recognize the patterns. A model that is kind of tell you that how a dog actually look like. And this process is called training. You might have heard people saying that I'm training my model. So it means that they go through again and again through this process to be able to find out how, for example, dog look like. Once it's all done, you normally have an application that talks to your model to find out, to, for example, send a picture, say that is it a dog, is it a cat, or then model, if it's just based on what information that it has, it answers back. So it looks pretty simple, but there are, of course, like everything else, there are challenges here. One thing is that, for example, finding a data set that contains all of this model. In our case, for example, finding a dog picture, you need to have a data set which covers all type of dog that exist, including dogs that might look like cat, like the one that I have, that is a Bichon Havanese dog. It totally looks like a cat, but it's a dog. So you need to have data set that cover a variety type of variation of the pattern that you're looking for. And the other thing is that creating and testing the result of this algorithm, it is not always easy. And also finding out which method to use in which time, which algorithm to use in which time, it's also not so easy. You might seen this picture before in many of the articles. Is the chihuahua or is it a muffin? So even for me as a human, by one look, I can't easily find out. So verifying the kind of that the outcome and accuracy of this result is neither easy. It requires a lot of time and resources. The other thing is that we all know that exposing the model to the app is also not always an easy thing to do. Or for example, scaling up the application or making sure that your input is secure, it is sometimes it can be challenging as well. And for sure, I haven't been through all of these things in order to create my app, since I also don't have a background as a data scientist either. So let's say that not a better way. Let's say that what is the easier way? I use Azure Cognitive Services. So what it does is literally it taking care of the whole process that I mentioned you here by training the model, having the data set, and then making it creating an REST API for me. So all I did, it was basically I talked to these cognitive services so it can recognize all of those face emotion that I was talking about. And since you can say that Azure Cognitive Services, it is machine learning as a service. And it sits on Azure, so by default, that is scaling up and having a secure endpoint, Azure taking care of that, so I really don't need to be worried about that. So we have a variety of these services. We don't have time to go through them. And what I'm going to do is that I'm quickly going to talk about the vision one, because that's what I used here. So and the vision service, it consists of a couple of different services. One is the computer vision. What it does, it basically describes this picture for you. So it can say that, oh, there are 4 humans standing there. With the accuracy between 0 and 1. Everything that it returns you is a JSON, and there is an accuracy there. 0, it means that I'm not sure. And 1, it says that I'm pretty sure. So you can also customize it and say that this is not a human, this is a stormtrooper. So I can do that as well. And Video Indexer, you might have seen the video that went viral some time ago with a guy playing violin and going through the rooms where everything is being detected there. You can easily use Video Indexer to do that for you. What I use, it was the Face API actually. Which we're going to talk more later on about it, but it detects everything about the face. And Ink Recognizer, that's a fun one that it recognizes the handwriting and also scatters if you draw something. So you can, for example, create a scatters and then change it to an HTML later on. We have some sample project for that as well. And then Form Recognizer, judging by the name, it bring you a key value of your form and the tabular data. So, and then Custom Vision, it lets you to customize all of these vision API based on your business suite. For example, that when I mentioned that this is a stormtrooper, not a human, that comes from there as well. So it's so simple. You to use it, you just create your service on Azure portal, and if you need to train your model extra to make it customized, you can do that. But I didn't do that. And you call the REST API, and it brings you back the JSON. And as for the Face API, this is a very sample version. I mean, this is the landing page of actually the Face API. That, as you can see, it detects the face, and that rectangle is always come there where the face is, and doesn't matter how many person is in this page, it recognizes them. And I use that rectangle to find out where actually I draw the emoji on the face as well. And there is a link here to the Face API. There are multiple different things that you can customize it there to for example, the parameter that you send, like I want to have the well-known landmark in the pages, in the picture. I want to detect that. For example, if I'm standing in front of Eiffel Tower, it recognizes it as well. So there are multiple things that you can customize it there. But for me, I was only interested in the emotion. And that's what I use in my application. And you can send either an image URL or an actual image there. So once you create it on the portal, you will get an endpoint that you can use it, and also an API key. So this is actually was all I did. I just created the service and I use this endpoint for my application. And of course, you all know that you can test it on the Postman. That's what I normally do to make sure that I use the I reach the kind of the result that I want for my application. And this is a sample result. As you can see that this is the part that about the face rectangle that is give you the position there. And these are, for example, the face attribute that it is showing you. And this is the emotion one, that it comes with the anger, content, disgust, fear, happiness, neutral, sadness, and surprises. And in this case, it was an absolute smile. So they said that I'm pretty sure this was a smile. So what I did in my simple application, as you could see that I had a video live view where I used the native video component that it exists, and then I had my simple button, and then I had my result in the canvas. And in my it was in my camera component. Then what I needed to, because I needed to have the element reference to the video and canvas, I used the view child in order to do that. And then I put some constraint here for my camera, that how it's supposed to be. And I'm using the render2 function for actually plugging to the video component. I will show you later on how I use it. And once the application was started and ng on it, I called my start camera function. So what I did here is that because we are getting access to the people's camera, of course they need to give their consent. Once they said yes, then what I did here is that I got the live view from the camera, and I attached it. I called my attach video method to kind of to bring that live stream of data to my video component. And this is how you do. It was pretty simple. So with the help of render function, I could actually achieve that, to get that stream of video to attach it to that video component. And that is what I achieved, that by this, that then I could have that live view of the camera here. So we have it up to here, but what we need to do is that we need to make it ready, that when I click the button, I capture like a snap of it, and then put it to my canvas. So because it's a live stream of data, first you also have to have the kind of that to listen to it, and then get the width and height of it, because we need it later on for the canvas. And once you click on the button, it calls a capture component, and this capture component is going to get that width and height from the video. And with that, we can have set the property of the native element that we have, and we put that capture of the video in our canvas. So we use this draw image method from the canvas to just draw it there. So after here, what I did is that we had the camera, we snapped it, and then we draw the picture. And what we need to do is that we need to send this picture. We need to translate it to a file and then send it to the cognitive services. So to do that, it was actually also pretty simple, because there is an already a kind of that element here that it create your canvas. You can create, in my case, I created a PNG out of my canvas, and then Azure Cognitive Services, it need a blob stream of image. So I need to convert that one to the blob. And this is a pretty, I'm not going through this method because that's a pretty standard way to convert the image to the blob. And once we have the file, then I called my detect emotion method, where I am talking to the cognitive services and get the emotion out of it and then create the emoji. So of course we need to have the header done. And what I did is that I just made a post, simple post with the API endpoint, with the file that we have, and with the customized header here. And when everything hopefully goes well, then I get that emotion because what cognitive services does is give you an array of face data, because it might be more than one. I get that array of face data, and I was interested only in the emotions, and that there is already an available class where it find that what is the closest emoji to this emotion. And in the service that I have there, so I get that one, and I create a new array where it is the position of the face and the emoji. Then I call the draw method, and I draw the emoji and the face, which is actually pretty simple again. So in this draw method, I have the array of faces with the position. I get a reference to my canvas, and then I need to do these calculations to find out that if because what I do is that those emoji is just like a font. So I need to do a little bit of calculation to make sure that the scale is correct, because when you are closer to the camera, your face is bigger, and then when your back is smaller. So I did some calculation in order to make sure that the scale is right. Once I have the font size set, then I just said that, okay, this is my emoji. This is the position in the left, and this is a position in the right. Just please write that emoji on my picture. And that's done. So that is how I created. So I want to just show you that here, when you go here, you see when I'm closer. Yeah, okay. So it does that, and then when I go back, I'm trying to be sad. Okay, it's late. I'm sleepy. So it does that for you. So if we go back here to the presentation, we are done actually. You see that what I created here, it was a kind of that very, very simple and funny application, but you can do a lot with all of these cognitive services that we have, and you can actually do something good, which is kind of that good for the planet that we have. We have AI.lab, where is like a portal of all the project, which is totally open source, and they are there for you to look at it and then get inspired. And one of my favorite one is the Snow Leopard Trust. project, which they uses multiple different of the cognitive services, and also with the machine learning study that we have, where they track snow leopards that they actually, we have a very low number of them there, and they could find a pattern to find the unique snow leopards, to be able to count them and observe the behavior, so hopefully they can help them and they can save it. So there are a lot of really interesting projects there for you to get inspired there. And that was the kind of that my quick presentation. And I wanted to actually here give you all a small present from my side and from my team. In my team, we created a new project which is called Azure Heroes, where we have two type of badges that they are based on blockchain Ethereum. So you can receive it unique badge by example. For here, if you scan this QR code, you will be able to get a very unique and limited edition of a summer learner badge in your digital wallet. When you scan this one, that you need to install a wallet from Engine, which is our partner, to collect these badges. We have multiple of them. That the award one is for you to kind of that to earn it as many times as possible by going to different events, listening to different talks, and going to hackathons. And we also have some recognition one, where I noticed earlier that Natalia, for example, was here, that she has the most valuable badge that we have, which is inclusive leader. This QR code is for you to is active for next 24 hours. You can always download that and download the wallet and collect this badge. And if you want to know more about the program, you can go to aka.ms/azure.heroes to learn how everything works there, and nominate maybe yourself for some of the recognition badge that we have, or some of your community friends, because Azure Heroes is all about recognizing and awarding the communities. And if you want to know that what people are talking about Azure Heroes, you can check the hashtag both on Twitter and LinkedIn. So people actually liking the project very much, and I'm so proud. So yeah, that's it. And thank you very much for listening to me. If you have time, I'm here to answer some of your questions as well. And my slide is already uploaded on aka.mss-mood-analyzer, where it consists of all of these resources that I have here, that I use actually to create this presentation. Thank you.
Thank you, Sherry. It was really cool to see all that. We got a question for you, so I'm gonna pop it up here.
Yes.
Are you able to read it there?
Yes.
Excellent.
So effective. So are cognitive services effective when we want to differentiate between an image that shows a piece of map and a black, white, or gray image? I guess it might be. Yeah, it might. I guess you need to. I should say that I'm not 100% sure. But as far as I know, I tried it in many different ways. That you can, for example, when you use the computer vision, it has ability to recognize a lot of things out of the box. But to be honest, I haven't tried this one yet. But I can check it out and get back to you too.
Awesome. Well, thank you, Nicholas. Thank you, Sherry, for being here. Thank you, everybody, for joining us and being part of this session. I just want to remind everyone that we're doing this monthly, and we have also another session of Angular this month because we canceled one of previous months. So we're gonna catch up here this month. So you can go in the video and see all the events that we have. We have any question, you can come to this.media. We have information about all the events. If you want to give a talk, if you want to be here, or just want to know more, please reach out to us. We're here to help you and help everyone share their knowledge so we grow as a community. And well, once again, thank you, Sherry. Thank you, Nicholas, for this awesome time, and everyone for joining us. I'll see you soon in the next session. Bye.
Thank you.
Bye. Thank you.